Hi all, I am Usha Ranian, Assistant Professor, JSS Academy of Technical Education, Noida. Today I am telling about the experiment, that is measurement of surface tension using stalagmometer. Surface tension is the tendency of liquid surfaces to shrink into the minimum surface area possible. A liquid or air interfaces. Surface tension results from the greater attraction of liquid molecules to each other than to the molecules in the air. The net effect is an inward force at its surface that causes the liquid to behave as if its surface were covered with a stretched elastic membrane. Thus, the surface comes under tension from the imbalanced forces, which is probably where the term surface tension came from. Because of the relatively high attraction of water molecules to each other through a web of hydrogen bonds, water has a higher surface tension than most other liquids. Surface tension is an important factor in the phenomenon of capillary. There are three factors that affect surface tension. First one, temperature. The surface tension of a liquid decreases with increase in temperature. This is due to the fact that increased temperature decreases the cohesive forces between the molecules. Second one is soluble impurities. The presence of soluble impurities may increase or decrease the surface tension. If impurity is less soluble, then surface tension of liquid will decrease. Next one is insoluble impurities. Insoluble impurities decreases the surface tension. Example, if there is dirt, grease or oil on the surface of water, then surface tension will decrease. And also one more thing, if impurities are more soluble, the surface tension of liquid increases. For example, when salt is dissolved in water, surface tension increases. So, surface tension is a result of unbalanced cohesive forces of surface molecules. When a liquid is allowed to flow through a capillary tube, a drop increases in size up to a certain point and then fall off. Here we used to measure the surface tension by drop volume method. So that is stalagmometric method. The stalagmometric method is one of the most common methods used for the surface tension determination. For this purpose, the several drops of the liquid leaked out of the glass capillary of the stalagmometer are weighed. That is why the apparatus used in this experiment is stalagmometer and rubber tubing, screw clip, water and given liquid. This method was first time described by Tate in 1864, who formed an equation which is now called the Tate's law. So that is W is the or weight of that one liquid is equal to 2 pi r nu. So where the r is the capillary radius and nu is the surface tension of the liquid here. The stalagmometer is also called as a stactometer, and it is this device this device is a capillary glass tube whose middle section is widened. The volume of a drop can be predetermined by the design of the stalagmometer. The lower end of the tube is narrowed to force the fluid to fall out of the tube as a drop. So, in an experiment, the drops of fluid flow slowly from the tube in a vertical direction. The drops hanging on the bottom of the tube start to fall when the volume of the drop reaches a maximum value that is dependent on the characteristics of the solution. Here we use the two solution, that is then only the equation it becomes m1 by m2 is equal to nu 1 by nu 2. Nu 1 and nu 2 are the surface tension of liquid 1 and liquid 2. So this is the stalagmometer. I explained it is that mark A indicates the before falling out of the liquid, and mark B is the end point of the liquid falls down. The procedure for this experiment: so fill a clean dry stalagmometer with water by sucking through the rubber tube until the liquid level rises above mark A. So the mark A is shown on the figure. And second one is close the screw tip tightly so that the water does not drop below mark A, and clamp the stalagmometer and carefully open the screw clip so that the drop rates comes to 15 to 20 drops per minute. Count the number of drops when water flows from A to B mark. Take 3 such readings and clean and dry the stalagmometer and repeat the same procedure taking given liquid in the stalagmometer. So repeat the procedure for the given liquid. So whatever you take down the drops, so you should mention in the tabular column. So that is for water and given liquid. So take the 3 trials, trial 1, 2 and 3, and take the mean value of all 3 readings for both water and given liquid. Before conducting the experiment, note down the room temperature. So then by using this formula, you can calculate the surface tension of given liquid. So here in this formula, N1 is the number of drops of water and N2 is number of drops of given liquid. So before conducting the experiment, you should know the precautions. Their stalagmometer should be thoroughly cleaned and dried, as surface tension measurement are highly sensitive to the presence of even minute traces of grease and impurities. So I already told you, so because of impurities, surface tension may vary. That is why this precaution must be you have to do it. And stalagmometer should be clamped in a vertical position, and any disturbance during drop counting should be avoided. Drop formation should be adjusted at a slower rate and should not exceed 15 drops per minute.